So from this, we'll have approached the end of this chapter, current electricity, and now we shall move to the worksheet exercises of this current electricity. Okay, children? Well, so moving ahead, worksheet number 3, level 1. First question, with increase in temperature, resistance of a conductor. What happens to the resistance of a conductor? Children, as the temperature increases, what happens? The vibration of the atoms or molecules increases. As the temperature increases, the vibration of the atoms increases. So, whenever the vibration of these atoms increases, they are obstructing the flow of electrons. The electrons may not be able to flow freely. So, whenever the electrons are not able to flow freely, the current across the conductor decreases. That means, with the increase in temperature, the vibration of the atomic particles increases. And these vibration of atomic particles obstructs the flow of electrons in the conductor. So, when the flow of electrons reduces, what happens? The current also reduces accordingly. So, that means with the increase in temperature, the flow of current decreases. With the increase in temperature, the flow of current decreases. But from Ohm's law, we know that V is equals to IR for a given potential difference. I is inversely proportional to R. Since V is equals to IR, for a constant potential difference applied across the ends, we have I is inversely proportional to R. As we have said that, as the free electrons decreases, the flow of electrons decreases in the conductor, the current also reduces. The current across the conductor also reduces. This results the increase in the resistance offered. Hence, as the current is decreasing, the resistance increases. So, clearly, the increase in temperature makes the current in the across the conductor decreases, and as a result, the resistance across the conductor increases. So, with the increase in temperature, resistance of a conductor increases. Hence, the correct option must be option number B, that is increases. With the increase in temperature, the resistance offered across the conductor also increases. Hope you understand. So, well, moving to the next question, second one. In series combination, what is that? In series combination, total resistance, what happens? So, series combination like this of resistor symbol, I told you, it is indicated something like this. Okay. Well, let us this be some R1, R2, R3, R4. Individually, we have only R1, only R2, only R3 and so on. Suppose if these resistors are connected in series, then the total resistance will be sum of the individual resistors, that is R1 plus R2 plus R3 and so on. Hence, the equivalent resistors increases whenever the resistors are connected in series. Okay, so in series combination, the total resistance increases. But the same resistors, when they are connected in parallel, then what happens? The current will be reduced, because the formula for parallel combination is 1 by R1 plus 1 by R2 plus 1 by R3, so on. So, in this case, the total resistance, because it is a reciprocal of all the things to be added, you will be getting something in decimals like structure to make you understand clear. Hence, during the parallel combination of the resistors, the equivalent resistors or the total resistance will be reduced, whereas in series combination, the equivalent resistors or the total resistance will be increased. So, as here it was said, as series combination, the total resistance must be increasing. Is that okay, children? So, well, the next question, in parallel combination, the total resistance. Just now we have discussed what happens in parallel combination, the total resistance will decrease. Okay. Well, the next question, in series combination, resistance increases due to increase in. Why does this resistance increase? Because what happens? The length of there is no topic regarding the temperature or humidity. What we observe is that during the series combination, what happens? The length of the conductor increases. The length will be increasing. So, increases due to increase in its length. So, option number C. So, why it is increasing? It is all because in the series combination, the length will be increasing. Well, in parallel combination, resistance decreases due to increase in. So, what happens here if you observe, so this must be, I'll mark it in a better way. So, this was your resistor and another resistor, and one more resistor. 4 resistors I have considered. So, if such resistors are connected in parallel, what we observe is that the area of cross section increases. All the resistors when connected in parallel, the cross sectional area increases. But the same when the resistors are connected in series, what we observe is the length will be increasing. Hence, what is the correct option, children? In parallel combination, resistance decreases due to increase in area. So, this is a pictorial combination, but I have already explained you in the concept wise that what we have, R is equals to rho L by A. So, this you already know. R is equals to rho L by A, where R is the resistance, rho is the resistivity, L is the length of the conductor and A is the area of cross section. So, here we go with, so here resistivity is always constant. It indicates the property of a given material. So, clearly we have R is proportional to L by A. R is proportional to L by A. That means R is directly proportional to L, whereas R is inversely proportional to A. So, as length of the conductor increases, resistance also increases. As the area of the conductor increases, resistance decreases. So, this gives you more clarity. So, what is that? In parallel combination, resistance decreases due to increase in area of cross section. Hence, option D must be true. So, this gives you more clarity. Okay. So, well, moving to the next question, when electric current flows through a conductor, the conductor becomes. So, because of the electric, take a conductor, take a metallic wire, continuously supply electric wire, and after a while what you observe, the wire gets heated up. Okay. So, the temperature of the wire gets increasing. So, when electric current flows through a conductor, the conductor becomes hot. So, option is 4th option, that is the conductor becomes hot. Well, the next question, when electric current flows through a conductor, what happens? Free electrons move, electric current flows through a conductor means of course free electron starts moving. Atoms will never move. There is no concept of atom. So, more number of electrons flow means more amount of current is produced in the reverse direction. Okay. So, hence because of the increase in free electrons to move, we have more electric current is being produced. The unit of specific resistance is, so what is the symbolic notation for specific notation, children? Rho, just now we have discussed R is equals to rho L by A. Okay. Well, and for rho, I can write down the rho as R times of A by L. This bringing to the left side will become the reciprocal. The unit of resistance R is ohm. And for area, it is area of cross section indicated with meter square. Length is measured in meters. If you simplify this, what are you left with? Ohm meter. So, the unit of resistivity is ohm meter. Hence, option C must be true. Ohm meter. Well, to the next question, ninth one. The reciprocal of resistance is conductance. Of course, we know that the reciprocal of resistance is conductance. If the unit of resistance is ohm, then the unit of conductance is. So, we know that resistance is, I'll write it something like conductance. What is the value conductance? They are telling that the reciprocal means, yes, the reciprocal of resistance. Reciprocal of resistance can be written as 1 by resistance is given as conductance. So, what they are saying, if the unit of resistance is ohm, so 1 by ohm. That's it. Then, what is the value of unit of conductance? So, conductance will be 1 by ohm. So, this 1 by ohm can also be written as ohm inverse. Okay. Or, I have already, while describing the concept, I told you that the conductance either indicated by ohm inverse or also can be written as mho. What is that? Mho. Hence, the correct option must be option number C, that is mho. What is the unit of conductance, children? It is mho. Okay. Well, moving to the next one, the SI unit of specific resistance. Specific resistance. Yes. So, the specific resistance is nothing but your resistivity. The other name for resistivity is also specific resistance. So, since R is equals to rho L by A and rho is equals to R A by L, its value is ohm meter square upon meter, and this is nothing but ohm meter. So, where is ohm meter, children? Here goes A, option A. So, this has two names. One is resistivity and other name for this is specific resistance. Two names are given for this. Yes. So, it has two names, children. Either specific resistance or resistivity have a same name and its unit is ohm meter. So, first one is true. Well, moving to the 11th one. The effective resistance of a circuit containing resistance in parallel is. So, whenever resistors are connected in parallel, what I said, the total resistance will be decreasing. When connected in series, the total resistance increases, and whenever they are connected in parallel, the total resistance decreases. So, what is the correct option? The effective resistance of a circuit containing resistances in parallel is, the total resistance will be smaller than the individual resistances. So, since we have 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. So, if R1, R2, R3 are the individual resistors, then the reciprocal of this will be added together. You will be getting a very smaller value. So, always remember that the resistance, whenever the resistors are connected in parallel, the effective resistance, the equivalent resistance or effective resistance, the total resistance, whatever is that, is always lesser than the individual resistance. That means R is less than R1, R is less than R2, R is less than R3 and so on. Okay. So, with this will be lesser than individual resistors. Okay. Which of the following have highest conductivity? Highest conductivity means more flow of electrons, more current should be able to flow. Okay. So, electrons should be able to flow very freely, then more current is being produced. So, then we say that the material will be conducting more. So, highest conductivity means metals are good conductors because they have good conductivity nature. Why? Because they are large number of free electrons are there in the metals. So among this, copper, of course it is a metal. Earlier we have discussed that silver, copper are all good conductors of electricity. Okay, because silver is a little costlier, so generally we will be using copper in our electronic equipments and all. Connecting wires, we will be using copper. Okay, semiconductors, they partially allow the current to flow through them, and insulator is a bad conductor. The insulators will not allow the electricity to pass through them. So what is the correct option, children? A, that is copper. Well, moving to the level 2 questions. Okay, so moving to the level 2 questions. In domestic electric circuits, the cheapest appliance is so, you know, fuse generally indicates, fuse wire. Okay, fuse wire itself is called as fuse, because fuse there will be, while our construction of the house only, they will be connecting along with the meter main. So, the fuses will be giving. Here, fuse indicates that fuse wire. That fuse wire hardly worth something like rupees 10 rupees to 30 rupees. That's it, children. So, it's very cheaper. That fuse wire is very cheaper in price. And in domestic electric circuits, means our household electric circuits, the cheapest appliance used is, the cost of fan, it will be in some thousands, and bulb will be about maybe some 40 rupees or 50 rupees. It may be not a small bulb. Bulb means that which glow and will be using for that general purposes and all. Okay, television, of course, it is a costlier. Okay, well, so which one is the cheapest one among these two? You may not have more knowledge regarding the fuse, but so fuse is nothing but fuse actually indicates that fuse wire. So small wire-like structure will be there. So it may cost something like 10 rupees or 20 rupees and so. So that is the cheapest one, children. Yes, children. 14th question. In a voltmeter, there are 20 divisions between 0 mark and 0.5 mark. Voltmeter, how it looks like. I have already shown you the instrument. It will be something like, say, 0, something. Yes. So, like this, some markings will be there on the voltmeter, and we also see that some pointer will be there, and this pointer indicates the reading of the voltmeter. Voltmeter generally indicates the potential difference across the two terminals. So, what it was given that between 0 and some 0.5, let me take 0.5 is here. So, between 0 and 0.5, what it was given is there are 20 divisions. Okay. So, in voltmeter, there are 20 divisions between 0 and 0.5. The least count of the voltmeter is, so from 0 to 0.5, totally how many divisions are there? Totally how much value is there? 0.5 volts. So, this 0.5 volts is divided into 20 divisions. So, 0.5 divided by 20. So, how much it would be, children? Something regarding 5 upon 200, 5 fourths. So, 1 by 40. So, 1 by 40 can also be written as 0.025, isn't it? 1 by 40 is equals to how much? 0.025. So, what is the least count? The least count of the voltmeter is 0.025. That means from here to here it is 0.025. From here to here it is again this is 0.025, 0.05, 0.75, 0.1, like that it will be going until 0.5. Okay. So, what is the least count, children? Least count means the smallest value that can be measured. In a scale, the least count is 1 millimeter, because every division is separated by 1 millimeter. Similarly, in the given voltmeter, every division is separated by 0.025. That means 20 divisions if you come across, 0.025 into 20 will be 0.5. That's it. Okay. Hence, the correct option is option B. Well, the 15th question. A man has 5 resistors, each of value 1 by 5 ohm. How many resistors are there, children? 5 resistors and each is 1 by 5. What is the maximum resistance he can obtain by connecting them? In order to get the maximum value of the resistors, we have discussed that they should be connected in series. So, if the how many resistors? If those 5 resistors are connected in series, like this is 1 by 5 ohm, here again 1 by 5 ohm, and here again 1 by 5 ohm, 1 by 5 and 1 by 5. So, when they are connected in series, you may get the maximum resistance. And what is the value of this maximum resistance? R must be equals to 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5. So, 5 times you are adding is the LCM is same. So, common denominator. So, that is 5. 1 plus 1 plus 1 plus 1 is, that is, you will be getting it as 5. So, if you simplify this, how much you are getting? 1 ohm. Hence, the correct option is option A, that is 1 ohm. Okay. To get the maximum value, you must connect it in series.